In last class, we have seen how to create. I'm going to share my screen now. Just a minute. Hope my screen is visible. Okay. In last class, what we have seen is how to create a DB design, right? How to we have gone through some plans of how to create an DB design for an application. Okay, before you are going through the collection of data and all the queries you are going to do in the table. Initial stage, if you are getting some requirement from your company, so how to do the DB design for that requirement. Okay. So likewise, we have seen some of the applications like sale data, and also the main thing is we have seen within hospital management, right? So with respect to the hospital management, what are all the master table we need, and what are all the lookups we need, and what are all the transaction table we need, right? Everything, and what are all the constraints we need to produce while designing the table itself. We have seen what are all the constraints. So not null constraint, primary key constraint, and the phone number should not exceed this much, and everything we have already seen. Using check constraints, we need to design all these things, and using primary key, foreign key constraint, we can able to create a relationship between the two tables. And using not null constraint, we can restrict the user to enter the null values. So likewise, we have seen all the table design and the relationship between the tables, and what are all the columns we need, right? What are all the columns we need for each and every table. Okay. So for patient, doctor, and everything we have already seen. And also, I have given you exercise with respect to the COVID vaccine track, right? Hope you guys remember that, and hope you guys completed that exercise also, right? In today's session, what we are going to see in today's session is one of the important topic is called as indexing. Okay, so indexing is nothing but just a minute. I am going to the PPT. So indexing is nothing but it is a technique. Okay, used in all kind of database. In Postgres, especially indexing, we are using it to speed up the data retrieval from the table by creating a separate internally. What the Postgres will do is internally it will create a separate data structure, and it will store the sorted copy portion of that particular data. Okay, internally it will do. If you create, if your part is just to think over on which table, on which column I need to create an index. By creating an index for the specific column, it should be more efficient. Okay, you should choose that kind of column in the table. Okay, so you have to create on index for the column. Okay, that is your part. All the other things Postgres will take care. You are not going to write any algorithm, and you are not going to write any sort of sorting and retrieving all those things. Postgres will handle. Okay, so the concept is why we are going to see in detail about the indexes. You have to know what the Postgres is doing internally. Okay, so that is very much important. Okay, so while creating an index for the table, okay, while creating a specific for the specific column in the table, while you are creating an index, so what it will do is internally it will retrieve the data from the table by creating separate data structure, and it will store the copy of the portion of data in the table. So indexing has a, so what it contains is, it contains set of pointers, okay, to to the actual data in the table. So that will allow the Postgres to quickly locate the and retrieve the required data. Okay, it's that particular pointer, a set of pointer it will maintain. So that pointer will fetch the it will quickly allow locate the data, and it will retrieve that required data. So internally all these things are happening. Okay, while creating the index, all these things will happen. See, Postgres supports many several kind of indexing technique. Okay, so by default, it will while creating the index, depends upon your query and depends upon the table you are creating and all those things. So it will consider all those things, and it will dynamically it will create whether it should be a B tree, whether it should be a hashing, or whether it should be a gist or gin or SP gist. So all these things it will take care automatically. Okay, so this is the frequently used thing by the Postgres. You see, after creating an index, what kind of algorithm it should use, so it is not in your hand. Automatically the Postgres will handle. Okay, so it supports several type of indexing algorithms. So the frequently used is B tree. Okay, so it see the B tree hashing, with respect to the hashing and B tree and the gist and all. Yeah, each and everything use different kind of algorithms, and which can be suitable for different use case. Okay, so for this particular use case, this could be better. For this particular use case, this could be better. That can be decided by the Postgres. Okay, so indexing can be created in one or more columns. We can able to create an index for more than one columns in an table in order to speed up the queries. So including some lookups. Okay, so you can see here for what are all the things we can use for lookups, and for a simple range queries. Okay, and for sorting kind of queries. Okay, and for grouping. Okay, so these are all the kind of queries they used to be used indexing in order to speed up the queries. Okay, so while creating the index, you should be very careful. You can use one or two rows as an index if the table is big, the columns are big. But with respect to while creating the too much of indexing also will slow down your performance. So that is not recommended. So you have to be very careful while creating an index. So now, so the B tree is nothing but a default indexing algorithm Postgres is using. So it is nothing but a balanced tree. Okay, used as a balanced tree data structure and organize the data. So the B tree, with respect to the B tree, it allow you to do it is very faster. Okay, faster in search, faster in insert and deletion, and it can able to handle the large datas. Okay, the specialty of the B tree is it can able to handle large datas. Okay, data set, large data set, and what else? It is a faster. Okay, and it is faster while doing the insertion, deletion, right? So all kind of operations, it is much faster. Okay, with respect to the hashing index, we use the hash function to map the index column and to fixed size of the index. So all these kind of a B tree, hashing and everything you have studied in the data structures, right? So binary tree, B tree algorithm. So everything you people have already studied in the most of the people who are attending this session is final years, right? So you have already studied all these things in your data structures, right? The hashing used a hash function to map the index in the column and fix its size. So the comparatively, when you are using when Postgres is using the hashing, it's not that much effective when compared to B-tree, because hashing is much faster, but we cannot use for the range queries. Okay, the Postgres is not recommended it for some range queries. Okay, so that everything Postgres will handle. But in order to know what is mean by hash, what is mean by B tree, I'm just going to explain everything to you. Okay, so you are not going to write any algorithm, you are not going to write anything. I will tell you after doing query how to create indexing and how it will handle. Okay, I will tell you with an example. But all these algorithms and all, you are not going to write with respect to the Postgres. Okay, just in order to know what is happening inside. Okay, after creating an index, it is very much important. Without knowing what is happening inside, you cannot able to proceed further, and you cannot able to optimize the code, and what kind of index, what for what column it should be efficient to create an index and all. It will be very tough for you without knowing all these things. Okay, so just in order to know what is happening internally, this is important. So gist is nothing but a generalized search tree. So this will use different kind of algorithms, and especially this use the tree structure and organized data. So supports a wide range of search operations. Okay, it to use including the geometric data also. Okay, for the full search, text search, and also the space. You can consider this SP just is nothing but for used to store the spatial data, coordinates, latitude, longitude, spatial data, polygons, and all those kind of data spatial kind of queries, on all those complicated things can be processed using just. Okay, by creating this just. Okay, internally everything Postgres will handle. So here we are going to see one small example about B tree. Before going to the B tree, why we are not using the binary search? Okay, so the binary search is a very very simple set of algorithm, right? So binary search, you are all people, we are just going through one glance of binary tree. Okay, binary search algorithm. So binary search algorithm is nothing but first it will take the center point of the if it is if the numbers are 1 2 3 4 like that, it arrange it after sorting it take the center point. And while inserting, okay, so this is the step. First compare the element to be searched in the root of the element while inserting. Okay, while inserting it will search for, first it will take the 8. Okay, if the number, incoming number, for example, I'm inserting 10. So while the incoming number is greater than, first it will check for the root. This particular number, this 8 is root. Okay, this it will check the 10 with root while inserting. Okay, while inserting the 10 initially. So if it is lesser, then it should go to the left side. If it is greater, then it should go to the right side of the subtree. So similarly, likewise, we used to insert. If the incoming number is 3, then it will insert the number as an in the left side. So if the incoming number is 6, so it goes here, it will check, and it is less than 8, so left. So again it will check. Again it will check with the 3. So 6 is greater than, so it will insert in the right side. So simple concept with respect to the binary search tree algorithm. So if the incoming number is less than the root, it will insert in the left side. Otherwise, it will insert in the right side. Similarly, the travel goes on. Okay, this is the simple thing about the binary search tree. So this is the procedure they are following with respect to the binary search tree. So why they have avoided the binary search tree in all kind of things is, so practically it gives the poor performance with respect to the memory usage. So you can see if there are lakhs and lakhs of thing or there, it has to maintain the tree structure like this and pointers and everything. It has to maintain, and there is a more memory usage also with respect to this kind of structure, right? So it is very difficult to maintain with respect to the memory usage and also the poor performance. So they have avoided the binary search tree algorithm and move forward with respect to the B tree algorithm, which is known as a balanced tree. Okay, balanced tree. So for the simplicity purpose, in order to understand you, in order to make you guys to understand, I have just explained about this binary search tree algorithm. Okay. So similarly, this B tree is nothing but B tree. B tree follow the rules one step ahead for with respect to the binary search. Okay, in order to improve the performance, in order to make the memory usage and everything, lesser memory usage and everything, the improvised version. Okay, the B tree is nothing but an improvised version, a balanced tree. Okay. So this is the algorithm which they followed in the binary search. So first it will come to the root. The step one is it will come to the root. If the root is null, then it will return the root. Or the data is equal to the root, then it will return the root itself. Otherwise, it will, if the item is less than the root, then it will go for the left. And if item is greater than the root, then it will go for the right and end. Okay, the same step is going to repeat. Okay. So this is what the binary tree search algorithm. Okay. So similar kind of algorithm they used to follow in the B tree with, but with an improvised version. Okay. So all the leaves are should be at the same level. The tree is defined in terms of a minimum degree is T. So all these kinds, these are all some of the properties they used to follow while designing the B tree. Okay. So, like other balanced binary search tree, the time complexity and all the deletions and everything is efficiently handled. Okay, so this is how the B tree looks like. You can see here. This is how the B tree looks like. So the B tree are characterized by the large number of keys they can. So how they have reduced this kind of memory issues and everything, how they have reduced is they follow the large number of keys, okay, in a single node. In the single node, they can store in a single node. Large number of key can be stored in the single node. You can see here with respect to this node. So this is a center point with respect to this node. If the incoming number is suppose 50, how they have handled, you can see it will come inside the single node itself. They have handled a 3 range. Okay, if it is less than 35, then it will store here. If it is greater than 65, it will store here. If the range is in the middle range, okay, 35 to 65, then it will store. So all those pointers are, okay, they have maintained all those pointers within this range itself. So now we can able to handle the keys efficiently with respect to the memory and everything. And disk space also it handled in a very less when compared to all the other algorithms. So this is how the B tree works. Okay, B tree works, and these are all some of the characteristics of B tree. Okay, just we are going through the glance, not in depth. Okay, I'm not going to teach you about all those insertions, deletions, algorithm with respect to some Java or Python language or C language, anything. I'm not going to handle all those things because already you are in final year. People have gone through all these kind of algorithms in the data structures, right? So this is just a glance what is mean by B tree, right? So how they have handled the B tree. It contains the multiple keys which allow you to have the large branching factors and shallow the height. So when compared to the binary tree, they have reduced the height, and also they have the keys they have used as inside a single node. They have used many keys. Likewise, they have reduced the height of the tree in order to maintain the optimized way. Okay, in order to do the optimization with respect to the memory and also the faster search. It will do the faster search. So this is the just a glance of a B tree. Okay. So likewise, the Postgres will handle the hashing and the gist, gen, sp, gist, all these algorithms. The Postgres will handle internally. Okay, this is all about the indexing. Okay, just a glance about the indexing in Postgres. So you are not going to write any algorithms or anything with respect to while writing the queries. Okay. So internally everything the Postgres will handle. Just this kind of algorithm internally the Postgres is doing all these kind of things internally while giving the indexing. That is the one which you have to know. Okay. Before going for the indexing topic. So now what I'm going to do is I'm going to write the query and I'm going to create an index for that. Okay. So now we will take the same invoice master, invoice master or invoice details, item master and everything. Now what we are going to do is I'm going to find with respect to any item, any one item with some var condition because indexing works efficiently while doing the var condition and grouping and joining. Okay, joining the table, all these things. When we are doing all these things, it will while doing these kind of queries only, indexing works efficient. In the complete efficient, we can bring out the complete efficiency of an indexing while doing this kind of queries only. Okay, so now what we are going to do is I'm going to create a one query in order to find the maximum value. Okay, with respect to the items sold. Okay, with respect to the items sold in the maximum value I need. Okay, maximum value of an item sold. We will take only one item. I'm going to filter only one item. So like this, we can do it with respect to grouping and using var condition and everything. We can able to do it. Okay, now I'm going to write the query. Okay, so what is the query means? I need a maximum value of in this item. Okay, this item. So I need this item ID is here. I need the maximum value which got sold. Okay, which got sold with respect to all the items. Okay, so we will go on to the query. So what I'm going to do is I'm going to do a select. So from where I'm going to select, firstly I will write the table names and also with alias names, so that only it is easy for us to choose the columns inside the table. Okay, what are all the two columns which we need is from what is the thing, item master, right? Item master, I will keep it as an item master as I. Okay, and I'm going to join one more table is called as invoice details table, right? So I will keep this particular table as D. Okay, let it be. So what I want is, I want any two columns from this table. I'm going to choose the item ID and the item. Okay, I will choose I dot item. Respect to the item ID only, we are going to join, right? Item ID equal to, sorry, item ID comma I dot item, right? And one more thing, what we need is from this details table, we need the value. So what value? We need a maximum value, right? Max of d dot value, right? As highest value, right? Let's see, we have already having highest value. We can keep this name. Okay, this is just an alias name. So now I am going to join these two tables on what condition? My item ID, right? Item ID in the item master should be equal to item ID in the item ID in the invoice details. So that is the condition we are going to. Okay. So now what we are going to do is I'm going to do some group bys. Group by. So group by what are all the things which we are giving inside the given inside the select statement should come in the group by also. Otherwise the error will come. This part I have already told you. Order by. What is the order of the items? So I will take everything. Okay. As well as the highest also I will take. So this much of order I have given, and I have given the group by. Let me take one more where condition also. Okay, okay, I will take one where condition. If it is with the where, then I can show you the um, complete efficiency of an indexing. So, for example, I have taken this var condition is not needed, but just for example, I will take for this particular item for one item. Okay, item one. Sorry, item ID one. So I'm just doing the group by with respect to the items because we are having many items with inside the item one itself, right? So this is the item one. So I have chosen just this item only. So it means it has chosen the group by is also not required, but we will do for mm, item. Okay, I will take that. Then item. Okay, we will go ahead with this query alone. Okay, now we'll just see whether it is working or not. And what else? Okay. I'm just opening the PostgreSQL. So I'm going to connect it with my database. What is my database name? NMDB class. So you can see here. I'm just pasting this. Mm, Oh, I have given some spelling mistake, I think. Yes, here you can see. Given it with some spelling mistake. Okay. Now we are getting just with respect to the item one, what is the highest sale? Okay, like that we have given. So with or without group by or everything, we will proceed. So now what I'm going to do is I'm going to create an index. Create. So what is the syntax to create an index is create index name. Okay, index index name. So whatever name it should be meaningful. Okay, index name on table name on which table you are going to create an index. Inside the bracket you have to give on which column you are going to create an index. Okay, column name, right? So this is the syntax for the index. So now what I'm going to do is I'm going to create an index for what? Okay, I will create an index for instrument. I am going to create an index for invoice details. Okay. So while creating an index for invoice details only, so I am doing search on the max of value, right? Here I am with respect to the item ID. You can see here with respect to the item ID. Okay, with respect to this item ID, see here how many items IDs are there. There are nearly 20,000 items IDs are there. So while creating an index for this particular item ID, so and also I'm searching one particular value, right? The max of value with respect to the ID. So while doing this, this will while doing this while searching the while searching the item ID, what it will do is the Postgres will initially it will search with respect to the while if we didn't create any index, it will search one by one, 1, 2, 3, 4 like that. Okay. So after creating an index for this item ID, what it will do is it will search in this manner. Okay, it will search in this manner. So it will separate we will take this as an example. It will separate it will take the center point, and it will separate it like 35, 36 like that, greater than and less than. So if it is less than 100, then it should come left. If it is greater than 100, then it should. So priorly after creating index, it will create one structure like this with respect to my item ID. Okay, for all this kind of item ID, whether I'm if I'm creating it for an invoice ID, it will create one structure like this. If it is for an item ID, it will create one structure like this internally. So that particular pointer, I have already told you that particular pointer, what it will do is internally, instead of searching each and every element, so you can see here, it will search for 1, 2, 3, 4, 11, 12, 13 like that. It will search for, instead of searching all these elements, what it will do is it will search only half of the thing. Okay, for example, if I am going to fetch the value 90. Okay, for example, if I'm going to fetch the value 90, first iteration, it will comes to the 100. Whether it will check whether it is equal to 100 or not. No. If the 90 is less than 100, right, then it should goes to left side. So it will check these two things. So if it is greater than 35, then it will jump on to, and it will check the middle, if, whether the 90 is in between range. No, it is not in between range. And it comes here, and it will check the whether the 90 is greater than or less than. So it is greater, then it comes here, and it will easily it will fetch the 90. So under 1, 2, 3, only one 3 to 4 iteration, okay, easily that pointer will find the particular value. Okay, but in the traditional search, like without using any indexing, or without using any algorithm, it should goes one by one, right? 1, 2, 3. So in order to get the 90, it will goes on finding the search. It will goes on finding the numbers until it get 90, right? For 90 iteration, it will goes on. So it is very costly with respect to time, and also with respect to all those memory issues and everything. So it is very costly. So after creating the index, this kind of index, okay, so what it will do is it will arrange all the, with respect to item ID only, I'm going to proceed with an index. So it will arrange internally, it will arrange all these items with respect to this kind of some tree structure, and also with the pointers and everything. So after creating an index internally, what the Postgres will do is, let me show you. So I'm going to create an index for the which table? Invoice table. Okay, invoice details table. And this name is, it is up to you. Okay, you have to give some meaningful name. So now I'm going to create an index for this item ID, and usually we use this. Okay, IDX is nothing but item ID. IDX is nothing but it represents the index. Okay, this is not any predefined or the keyword or anything else. It's just for naming purpose. On seeing this, it is a common name which we use. IDX. Okay, like this we can be able to identify that okay, this name belongs to some index, like that we can able to identify. So what column we are going to create an index? Item ID is the column name. So now what I'm going to do is, you can see here, now I'm going to create, what happened, in, not in, on. Okay, on. On is the keyword. Okay. So I'm going to create again. Okay. The index got created. For which table? Invoice detail table. I will show you. Let me try to increase the font size and I will show you. You can see here. Here is the index name and a B tree. You can see by default it has created an index as an B tree. B tree is nothing but we have seen this algorithm, right? B tree. So this is the algorithm which it is following, and these are all the properties of B tree. Internally, Postgres will do all these kind of algorithms and everything internally it will do. You don't need to mention, or you don't need to write any algorithm or anything with respect to the indexing. So internally Postgres will take care everything. Okay, but you want to know, you need to know about what is going on internally. Okay, so that only you can able to handle efficiently with respect to the columns. Okay, which column is it will be efficient while creating an index. Likewise you have to know. Okay, so after creating an index, I have created an index. So okay, I will try to drop this and show you before and after creating an index what is the difference. Okay, so now what I'm going to do is I'm going to explain this query. So explain in previous session itself, you people already known about the explain, right? The what the explain will do. In previous session, while Thursday or Friday, Ramkumar has handled this explain and all everything, right? So I think you people aware about this explain. What this explain will do is it will explain line by line of the query, the cost of the query, what kind of algorithm it is using, how much cost it is consuming. So everything it will explain. Okay. So I'm just dropping this index now. Drop. So in order to drop this index, this is the query. Okay. Drop index name. Okay, I will just drop this index. Okay. So I will just drop this index and I will try to explain. Okay, I'll just do this. Okay, you can see here what is the cost. So what is the total cost? Cost with respect to this cost means is nothing but it will take combined together. It will take all the what do you mean CPU, memory, and how much time it is taking to execute for each and every grouping or order by everything. How much cost so it is a combination of everything. So it's not only the time. Okay, with respect to CPU and memory, everything it consider, and it will gives you one cost. Okay, so now the cost is this much. So you can see here for looping, for a sequential scan in the item master, how much time it takes. And in order to in order to do the sequential scan in an invoice detail, how much it takes. In order to do the aggregations, how much cost it takes. So what is the group key? Here it took the item ID because that is the index key, right? So this is the with respect to the explain of. So if you give any query inside the explain of, it will gives you all these details. Okay. So this is the query plan, which is which the Postgres is doing inside the internally. Okay. While you are giving the query, this is what the Postgres is doing internally. Okay. So now you can see the cost. I'm going to create an index now. You can see here I have created one index, and now what I'm going to do, I'm going to give the same query. Let us see. This is very small table. I don't know how efficient it is. It is reducing the cost. Of course it has reduced the cost. You can see here after creating an index how much cost it got reduced. Okay, So how much it got reduced? Previously it is 414.20. Now it is 177.97. Okay, so hope you guys understood all these things. That's why after creating an index, why we are creating an index. Okay, so by default, usually it takes only B tree. Okay, so what is mean by B tree? So what is mean by indexing? It is a technique used to speed up the data retrieval from the table, right? While creating it internally, it will create one separate data structure and stored the all the sorted copy of the table, and it will set one set of pointers. Okay, it will set one set of pointers, and to do that, the pointers to actual data in the table, which allow the Postgres to quickly locate and retrieve the required data. So this is what internally the Postgres is doing with respect to indexing. Okay, hope you guys understood all these things. Okay, I will tell you one more example also. So I will show you. We will do with some distinct on. Okay, we will do with the distinct on also. Okay, so I will take. Okay, I will take this distinct on invoice in the invoice table. Okay, for the same highest value, I will do the distinct. Let us try to do the distinct on, and we will do some joins, and we will do some ordering. Let us see how it will react for the distinct on. Okay, this is just a trial. I will try. Okay, select. So the same thing, same query. We will take the same query. The same thing we can use it with the distinct on also, right? Otherwise, we will take this date. It will be efficient, right? We will take this date with respect to this date. Okay, then it will be whether we will see. Okay, whether it is efficient or not, we will see. So instead of giving this item ID, I will give invoice ID. Okay, invoice ID, and I will do go for the distinct on. Distinct on. We have already seen why we have used a distinct on of. Okay. So for this particular column, so I will take the okay, instead of this item, I will take invoice date. I need to display the date for this particular date. What is the maximum value? Okay, we will go in that manner. So from invoice master, right? Instead of using item master, I will use the invoice master. So now what I'm going to do is I'm going to join it with the invoice details. Okay. So with respect to invoice ID, here also with respect to invoice ID, invoice ID. So DD, I is the alias name and D is the alias name. We don't want this. Okay. So with respect to all the items, I'm going to fetch. So instead of giving this group by, what I'm going to do is I have joined everything and I have given the order by. Okay. Order by with respect to the what is that invoice ID I have used, right? So I will use the same thing. So with respect to invoice ID, I'm going to do the order by. Okay. So in descending order. Okay. So let me execute this, whether it is working or not, whether I have made any mistake on. Yes, what is the invoice ID must appear in the group by class. Okay. So I'm okay. I don't want this max. So while giving the aggregate function, I need to give the group by, right? So I have given the distinct on, right? So I don't want that. So you can see here for each date, okay, what is the highest value? So for each invoice ID with respect to date, what is the highest value? Okay, here I have used the descending order, and we have already seen it will brings on for each subset. Okay, it will do the group by for each subset, and it will brings on the descending order of each subset, and it will brings on the first items in that particular subset. Right, this is with respect to distinct on we have already seen. Okay, so for this query what I'm going to do is I'm going to do the explain, and also I'm going to create one index. Okay, so invoice, we will keep this as an invoice ID. And what is okay, I will go ahead with the invoice details itself. Okay, so invoice ID, I'm going to create an index for this invoice ID. So without yet, I didn't create the index for this invoice ID yet. Okay. So I will show you with and without creating an index, the cost, how it has reduced the cost. So let me copy this and paste it. Now I didn't create any index. What happened? Syntax error. So you can see here, I didn't create any index yet. And you can see the query plan and what is the cost. Right? By using the distinct on, what is the cost? By after using distinct on, and I have joined these two tables and everything I did. Right? So while doing join and everything with respect to the date, right? With respect to the date column. So here I have created index. Index for what? Invoice ID. Okay. So now after creating an index, what is my query plan? You can see here how much the cost got reduced. How much the cost got reduced, even for you can see how many rows are here. How many rows are here? Count is um, only 1,245 rows are there. No, nearly 20,000, I think. That much only. Huh? Oh, okay, 1,245 rows, right? And this 1,245 rows with respect to the invoice ID, it should match, right? For each and every ID, it should match, and it should do the some sequential scan inside. And you can see here, it used after doing indexing, it used a merge join. Before that, it used hash join. After using index, it used the merge condition, merge join. Right? So while creating an index itself, on seeing all those queries and everything, internally Postgres is changing itself, right? Changing the uh, whether it should use what kind of hash join or sequence join. So in previous thing and all, they have used the sequence join, I think. So you can see the sequence scan, right? So they have used this sequence scan here. He used can see here he used the hashing technique. So internally, the Postgres is handling everything. Okay. So what you need to do is you need to choose the column efficiently. Okay. You need to choose the column efficiently here with respect to the invoice ID, and it present inside the invoice details. Okay. I didn't create any index with respect to the invoice master. Right? I have created with respect to the invoice details. While doing the join, so it should be efficient with the master table. So I have created an invoice, the indexing with respect to the invoice ID in the transaction table, not in the master table. Right? So by doing that, we can able to see. So it depends on the condition. Okay, it depends on your requirement whether you are going to create an index with respect to master table or transaction table or anything. It depends on the requirement. Okay, and what kind of joins and how many joins you going to use and how many conditions you are going to give. So it depends upon. So you need to think over it with respect to the requirement. See how much cost it got reduced, right? So while using the indexing for this invoice ID present inside the invoice detail. Okay, after creating an index and before creating index, you can see the difference. Okay. Now what we are going to do is I want you to create, okay, I want you to create a same kind of indexing. Okay, I will give you exercise. Before that, we will go for the poll questions. Okay, so I'm going to stop the recording.